Dear students, today we will discuss about seventh experiment of applied thermodynamics. The aim of experiment is to study alternative fuels for IC engines. The increasing industrialization and motorization of the world has led to steep rise in demand of petroleum products. Due to rise in demand, petroleum products will become very costly. There are limited reserves of these fossil fuels and not renewable. Also, these finite stock of petroleum are highly concentrated only in certain regions of world. Hence, it is important to look for alternative fuels. Another reason for motivating the development of alternative fuels for IC engine is the emission problem of petrol and diesel engines. Now we will discuss some alternative fuels. First one is ethanol. Ethanol can be made from ethylene or from fermentation of grain and sugar. Much of it is made from corn, sugar beet, sugar cane and cellulose. Ethanol can be blended with gasoline to create E85 and E10. E85 blend 85% of ethanol and E10 blend 10% of ethanol. E85 eliminate coal starting tank flammability. It is an alternative fuel under Energy Policy Act of 1992 vehicle that run. Second one is the hydrogen. Hydrogen has been used efficiently in a number of IC engine vehicles. It is very advantageous to use hydrogen as a fuel for IC engine. There is no carbon in fuel, so no CO or HC in exhaust. Due to this, low emissions are produced. Fuel leakage to environment is not pollutant. There are a number of different ways of making hydrogen, so fuel availability is greater. Okay. Then third one is methanol. It is also known as wood alcohol. The most common mixtures are M85 and M10. M85 contains 85% of methanol and 50% of gasoline. Also, M10 has a mixture of 10% methanol and 19% of gasoline. With M85 fuel, there is a measurable decrease in HC and CO emissions. Emissions from an engine using M10 fuel are about same as those using gasoline. The advantages of using this fuel is the 10% decrease in gasoline use. Fourth one is biodiesel. It is a clean diesel made from natural renewable sources such as animal fat, used vegetable etc. Biodiesel operates on CI engine blends up to 20%. It reduces emissions of unburnt HCCO and NOx. Then fifth one is a natural gas. Natural gas is a mixture of 60 to 95% of methane with small amount of ethane, nitrogen, CO2 and other hydrocarbons. It is stored as compressed natural gas, that is CNG, at pressure of 16 to 25 bar. Also, it can stored as liquid natural gas, that is LNG, at pressure of 70 to 210 bar. Octane number of this fuel is 110 for SI engine. Due to this, engine can operate with high compression ratio. Also, this fuel produces less emissions after burning. Then sixth one is hydrogen compressed natural gas, that is HCNG. The natural gas can be compressed and then it is called as compressed natural gas. Addition of hydrogen into natural gas increases burning velocity of mixture so as to increase thermal efficiency. The blending of hydrogen with CNG lowers the emission from engine. Then seventh one is liquefied petroleum gas, LPG. LPG is stored at pressure of 70 to 210 bar at around minus 160 degrees Celsius temperature. For automobile engines, two types of LPG are used. One is propane and other one is butane. LPG mixes with air at all temperature. LPG has high anti-knock characteristics. Running on LPG translate into cost saving of about 50%. Emission is much reduced by the use of LPG. Eighth one is dimethyl ether DME. DME can be made from a variety of fossil feedstock including natural gas and coal. DME is simplest ether consisting of two methyl groups bonded to a control oxygen atom. Its low auto temperature, high octane number, low running cost and reduced emissions without large sacrification in vehicle performance. Okay, these are some kind of alternative fuels used for IC engines. So conclusion is we have studied different type of alternative fuels with their characteristics. Thank you.